Drones are changing the world. They deliver packages, inspect bridges, and even help farmers. But building these flying machines can be slow and expensive. That's where 3D printing swoops in. Imagine creating a whole drone with just a printer and some raw materials. This isn't science fiction, it's becoming a reality. 3D printing, also known as additive manufacturing, builds objects layer by layer from a digital design. It's like magic, but with plastic, metal, or even carbon fiber. This technology is revolutionizing how we design and build things, and drones are leading the charge. With 3D printing, we can create lighter, stronger, and more complex drone designs that were impossible before. We're talking about drones that can fly farther, carry heavier payloads, and stay in the air longer. This technology is not just changing the game, it's rewriting the rules altogether. Now, you might be wondering, can we really 3D print an entire drone? Almost. The body, wings, and even some internal parts can be 3D printed. But what about the battery, the motor, and all the electronics? Let's talk materials. We can 3D print with strong and lightweight plastics like nylon and ABS. For high-performance drones, we can even use carbon fiber reinforced materials. These materials are ideal for creating the drone's frame and outer shell. Powering these drones requires lightweight batteries. Lithium polymer batteries are commonly used. While we can't 3D print batteries yet, the drone's design can be optimized to house them efficiently. The brains of the drone, including the flight controller and sensors, are still manufactured separately. However, 3D printing allows for intricate designs that integrate these components seamlessly into the drone's body. One of the biggest advantages of 3D printing is automation. Traditional drone manufacturing involves a lot of manual labor. Workers assemble parts, connect wires, and perform quality checks all by hand. 3D printing automates much of this process. Imagine a design being sent to a printer, and hours later a nearly complete drone emerges. This reduces the need for manual assembly, saving time and labor costs. Tooling is another area where 3D printing shines. Traditional manufacturing often requires expensive molds and tooling for each part. With 3D printing, we can create complex shapes and designs without the need for specialized tooling. This saves both time and money. Fewer errors, less waste. That's the 3D printing promise. Since the process is highly automated and controlled by computers, there are fewer chances for human error. This leads to higher precision and less material waste, making it a more sustainable option. The price of progress, analyzing cost differences. At first glance, it seems like producing drones in China is cheaper. However, several factors contribute to these cost differences. China has a more established manufacturing ecosystem for electronics and 3D printing materials. This means they can access cheaper materials and components, giving them a price advantage. India, while rapidly catching up, is still developing its domestic supply chain for these technologies. This leads to higher import costs for materials and components, driving up the overall production cost. However, India has a competitive advantage in terms of labor costs. Wages for skilled labor in India are generally lower than in China. This difference is reflected in the lower labor costs for drone assembly and testing. The investment in technology and automation also plays a role. China has been investing heavily in automation and advanced manufacturing technologies for years. This gives them an edge in terms of production efficiency and lower labor costs. Let's talk numbers. China and India are major players in the drone market. Imagine we want to produce 1,000 long-range drones. Let's break down the costs. The cost of materials like carbon fiber composites ranges from $1,500 to $5,000 per drone. China tends to have slightly lower material costs due to its established supply chain. Industrial 3D printers cost between $1,000 to $3,000 per drone in both countries, depending on the complexity of the design. The power system, whether it's a lithium-ion battery or a hybrid engine, will set you back between $2,000 and $5,000 per unit. You'll need advanced navigation and sensors, which could cost $1,000 to $3,000 per drone. Since 3D printing reduces a lot of manual work, labor costs are lower than traditional manufacturing, ranging from $2,000 to $5,000. Finally, assembling and testing the drone could cost around $500 to $2,000 per unit. Comparison between China and India. So, how do these costs stack up between China and India? Here's a quick recap. In China, the total cost to produce 1,000 drones ranges from $7,500 to $15,000 per drone. In India, it's slightly higher at $8,000 to $17,000 due to some additional material and production costs. From factory to flight, timelines for drone production. Time is money, especially in manufacturing. Let's compare the production timelines for 1,000 drones in both countries, considering both mid-scale and large-scale production setups. China mid-scale production, which involves a smaller facility and less automation, takes about 6 to 8 weeks. On the other hand, large-scale production, characterized by a larger facility and high automation, can be completed in 3 to 4 weeks. India. For mid-scale production with a smaller facility and less automation, the timeline is around 8 to 10 weeks. Large-scale production with a larger facility and high automation takes about 4 to 5 weeks. China's mature manufacturing infrastructure and higher levels of automation allow for faster production times. Their experience in mass production and streamlined processes give them a significant advantage. India, while making strides in automation, still relies on a mix of manual and automated processes. This, combined with a developing supply chain, leads to slightly longer production timelines. However, India is rapidly investing in technology and infrastructure to shorten these timelines. As they scale up production and adopt more advanced manufacturing techniques, we can expect to see significant improvements in their production speed. The future is automated. 3. D-printing and the evolution of drone manufacturing. The drone industry is on the cusp of a major transformation, and 3D printing is the driving force. As this technology matures and becomes more accessible, we can expect to see a surge in drone production, particularly in countries like China and India. Imagine a future where anyone can design and print their own customized drone at home. While we're not quite there yet, 3D printing is making this vision more attainable. This could democratize drone technology, making it accessible to hobbyists, small businesses, and even educational institutions. The environmental impact of manufacturing is also a growing concern. 3D printing offers a more sustainable approach, using less material and generating less waste compared to traditional manufacturing methods. As we strive for greener technologies, 3D printing will play a crucial role in making drone manufacturing more environmentally friendly. The sky's the limit. Embracing the 3D printing revolution. The convergence of drones and 3D printing represents a paradigm shift in manufacturing. This exciting frontier holds immense potential for innovation, economic growth, and addressing global challenges. As we've seen, 3D printing offers a faster, more efficient, and cost-effective way to produce drones. This technology is not just changing how drones are made, it's pushing the boundaries of what's possible in aerospace design and manufacturing. Imagine drones delivering medical supplies to remote areas, inspecting infrastructure for damage, planting trees to combat deforestation, or safeguarding the boundaries of a country to protect itself from its enemy's penetration. The possibilities are endless, and 3D printing is the key to unlocking this potential. Join the conversation. The future of drones is in our hands. The drone revolution is here, and it's powered by 3D printing. This transformative technology is reshaping the manufacturing landscape, opening up new possibilities for innovation and economic growth. As we've explored, 3D printing offers a compelling solution to the challenges of traditional drone manufacturing. From reduced labor costs to faster production times, the advantages are clear. And as this technology continues to evolve, we can expect even more groundbreaking advancements in the years to come. But the future of drones isn't just about technology. It's about people. It's about how we choose to use this technology to address global challenges, improve lives, and shape a better future. So, let's join the conversation. How do you think 3D printing will shape the future of drones? What exciting applications do you envision? The sky's the limit, and together we can explore the endless possibilities of this transformative technology. Thank you for watching.